Welcome to Math 63, Unit 2, Lecture 3. Part 1, we are rearranging formulas. What is a formula? A formula is an equation that shows the relationship between two or more variables. They could include fractions, they could have radicals, or they could have any other mathematical operation. Alright, so we want to rearrange a formula. Usually what we'll be doing there is isolating a given variable. Alright, here's the rules for doing something like that. Our first rule, okay, which is a special rule, and you'll see why in a moment, is expand brackets and collect like terms. That means simplify both sides of the equation so that they are as simple as they could be. Okay, they are each side of your equation is a algebraic expression like we've studied before, and we know how to simplify those, so you want to simplify them first. Then we've got these other rules. You could get rid of fractions by multiplying both sides by the lowest common denominator, or you could just multiply both sides by the denominators one at a time, whichever works best for you. You could add or subtract the same quantity or the same variable to or from both sides. So that's a thing you could do. You could multiply or divide both sides by the same quantity or the same variable, and you could take powers or roots on both sides. So you'll notice those last three rules have the words both sides in them. All right, that's really important, the both sides of an equation. Both sides is a really important idea, and whatever you do to the one side, you must do to the other. The equal sign is like a balance. Okay, so if you have an equation like I equals PRT, whatever happens to one side of this equation, we need to do the same thing to the other side so that our balance is maintained.
Welcome.
Okay, so
we're going to do an example here. I equals PRT.
Welcome.
Now this might have some meaning to you if you've done some business math before. We could have the interest is equal to the principal times the rate times the time. But if you don't know anything about that, that's totally fine. You can treat these just as symbols, and we are going to manipulate them just on a symbolic level. That's the beauty of algebra. We can totally abstract it from what it means. Okay. We're instructed to isolate for P. So what we're going to do now is look at how P relates to the variables around it and see if we can strip those variables off of it, and in doing so, with making sure that we do the same thing to both sides, those variables will end up on the other side of the equation. So right now P is being multiplied by R times T. So to undo that, we use the opposite of multiplication, which is division. And so I'm going to divide using the fraction line. I'm going to divide by RT. And whatever I do to one side of my equation, I have to do to the other. So I'll divide that side by RT. Now, on this side, the R cancels with the R and the T cancels with the T, and I'm left with P is equal to I over RT. Okay, and the nice thing about an equality like this is I could write it in either direction, and so just the way that English grammar works and the way that we like writing things, we'll write P is equal to I over RT. And there we go. So there's our first example. We've isolated for P. It's by itself, so if I had I, R, and T, I could figure out what P was. There we go. Okay, let's kick it up a notch here. We've got F is equal to 9/5 C plus 32. Okay, once again, this is an equation that some of you might recognize as the relationship between Fahrenheit and Celsius. But if you didn't know that, you wouldn't need to know that to answer this question. Okay, so that's, like I said, the beauty of algebra is it's totally abstracted from the meaning, which is also what some people don't like about algebra. but it makes it really easy to manipulate these things without having to think about what are these numbers meaning. We can think about that at the end. Alright, so I want to isolate C, is what I'm told to do. Okay, so now I'm going to look and see, okay, C is currently being multiplied by 9/5, and then that is added to 32. So what I'm going to do is try and undo that, right? Since we know from BEDMAS, from our order of operations, we know that C would first be multiplied and then we would add. Okay, so to undo this process, we're going to undo the adding first, and then we'll undo the multiplication. Right? So, in order to do that, to undo the adding, I am going to subtract 32 on both sides. So I'm going to subtract f minus 32 over here, and I have 9/5 C plus 32 minus 32, like that. And these will cancel. As you get better at this, you could skip this step. A number of you probably already do. Okay, skip it, writing plus 32 minus 32. But that's what we're doing. We are taking 32 away from both sides of the equation. So that gives me, now f minus 32 is equal to 9/5 C. Alright, now C is being multiplied by 9/5. So I need to divide by 9/5. Or another way to think of it is multiply by 5/9, because it's a fraction. Multiplying by the reciprocal is the same as dividing, right? So let's do that. So I'm going to multiply, well, let's write it this way. I'm going to divide both sides by 9/5.
Let's write it this way. I'm going to divide
which is the same
by 9/5
as multiplying both sides
as
by 5/9.
both sides.
So 9/5 cancels with 9/5, and I'm left with C.
9/5 cancels
So
9/5,
I could write
and I'm left with
C is equal to
So
f minus 32
C
times
equal to
5/9.
minus 32
And I could write this in a few different ways,
times
but it just told me to isolate C. I have done that. I am done. It didn't say I needed to simplify or anything like that, so we could leave this question like this and get our full marks. Alright, here's another example. We're told to solve for r. My equation is a equals pi r squared. You probably will recognize that as the area of a circle, but once again, even if you didn't need to know what this formula means to follow these instructions. Right? Solve for r is just another way of saying isolate r or isolate for r. Okay. So what we're going to do here is figure out, okay, what are the operations happening to r, and then we're going to undo them. So r has an exponent on it, so if I put a number in for r, I would square it first, and then I would multiply it by the number pi. Remember, pi here is a symbol, but it is actually representing the number 3.14159, etc. So I don't, so yeah, so it's not a variable. Anyway, but we're just going to treat it like any other symbol. So the first thing, though, is we recognize, okay, we've got this multiplication. That would have been the second thing if I had been doing the order of operations straight. So when I'm undoing, I'm going to undo the multiplication first. Right? So I will undo multiplication by division on both sides by pi. So that cancels out the pi, and that leaves me with r squared on the one side and a over pi on the other. Now, how do I undo squaring? To undo squaring, you're going to take a square root. So I'm going to take the square root of both sides of my equation, like that. And the square root of a square is the original number again. So r squared square rooted is just going to be r, so long as r was a positive number. Okay, so technically it's the absolute value of r, but for our purposes this will be fine for the moment. Okay, if there's ever a time where this actually needs to be the absolute value, I will highlight that. But for the moment, you can assume that almost everything we're going to be doing is going to have positive variables because we're talking about measurements most of the time. Okay, so that means that r is equal to the square root of a over pi, like that, which we could rewrite as r equals root a over pi. I should point out, though, that if you give me this on a test, that's full marks. This, if you want to write it this way, is just because this is how we're used to writing formulas, and we want to say, okay, the thing I want is equal to this mishmash of stuff. All right, so there we go. So that's how you solve an equation when there's an exponent on a variable that you want. You can then isolate by taking roots. Very good. Here's a more applied question. Okay, this formula is an important one in dosing. Okay, this formula connects body surface area to weight in kilograms and height in centimeters. So using this formula, if we had someone's weight and height, we could figure out their body surface area. Okay, which could be very useful if we had, say, a burn victim or something like that, and we needed to give them medication based off of their body surface area. We could now do that. Now this question says, find the formula to get someone's height given their body surface area and their weight in kilograms. Okay, so I want to, let's see, what do I want to do? So we want to get someone's height. So I want to isolate for the height is the idea now, right? And then body surface area and weight will be on the other side of the equation. So if I had those two, it would give me the height. Okay, so now let's think about what operations do I need to do to get h by itself? Well, if I had numbers here, right, and we were just doing order of operations, right, I would multiply h by w, then I would divide by 3,600. And then I would take the square root of that. And that would get me the body surface area. So to undo that process, the first thing we have to do is undo the square root, because that was the last thing we did when we were going forward. So to undo a square root is to square it. Right? So I'm going to take both sides of this equation, BSA squared will be equal to the square root of weight in kilograms times height in centimeters all over 3,600 squared. Now when you square a square root, both of them cancel out, and what I'm left with is just weight in kilograms times height in centimeters all over 3,600. And so that is equal to BSA squared. Okay, now I want to isolate h. That's the same thing I want to do, right? So, okay, what am I going to do for my next step? Well, I would have divided by 3,600, so I'm now going to multiply both sides by 3,600. I can just write that here, 3,600 times BSA squared, and times 3,600, so then I can cancel like that. Okay, notice the way that I'm writing this. I'm always being careful to do the same thing to both sides of my equation, so this equal sign is always true. I'm never going to just write down the 3,600 without also writing it on the other side. Okay? Good. So what I have on this side now is weight in kilograms times height in centimeters. So what I have on this side now is, and on this side is just 3,600 times BSA squared. All right, and what do I want to do? I want to isolate h. So what is stopping h from being by itself? Well, right now it's being multiplied by w in kilograms. So I shall
stopping
divide
H from being by itself. Well, right now
both
it's being
sides
multiplied
by W in kilograms.
So I shall divide
And W in
both sides by W
kilograms.
in kilograms.
And on this side, those will
W
cancel.
in
And so what I
kilograms.
have is H
And
in
on this side,
centimeters
those will
on this
cancel.
side, and
And so what I have
3,600
is H
times
in centimeters on this
BSA
side,
quantity squared all over
3,600
W in
times
kilograms.
SA quantity
All right, and we
squared
could
all over
rearrange this equation.
kilograms.
Just
All
flip
right, and we
the
could
equation so that we
rearrange
have
this
H is equal
equation.
to 3,600
The equation so that we have
BSA
H is
squared
equal to
over W in
3,600
kilograms. And now this is in a form that everyone seems to prefer.
over.
Okay, but as I said, if you're short on time, this is fine for full marks on a test. But if you're going to give a formula to your boss or something like that, they're probably going to want it written in this form.
If you're going to give a formula to
So there's some
your boss or
examples
something like that, they're probably gonna want it written in this
of
form.
solving for variables in a given formula. And
solving-
I hope to see you in class.
solving for variables in a given formula. And I hope to see you in class.
So there you have it. That's part 1. Okay, tune in to part 2 in a moment.